Welcome to the Data Hall YouTube channel. In this video, we are going to talk about how do we perform a two-way interaction in R. We had been discussing this categorical variable regression for past couple of videos. So in our first video, we discussed how do we perform a single categorical variable regression and how do we create its margins and margins plot. Then our next video, we discussed what if we have a multiple categories in a categorical variable. We discussed multiple categorical variable in regression, a categorical and continuous variable in a regression. In this video, we are going to focus on different types of two-way interactions. So what if we have a categorical and a continuous variable, two categorical variables and two continuous variables? How do we create its margins and margins plot, and how do we interpret the results? So let's start with the packages that we are going to use. We are going to use the ggEffect and tidyverse package. So let's load these packages, and then we are going to load our sample data. So let me show you this data. We have different individuals, their age, their marks, their salary, their gender, and level of education. So these two are categorical variables, and then the rest of the two are continuous variable, and the salary is our dependent variable. So if I want to perform the interaction between a categorical and continuous variable, first we are going to see how do we perform this interaction. So remember, by interaction we mean that there is a moderating effect of a variable. So for example, we say that gender let's say age do have an impact on salary, but this relationship is moderated by gender. So there is a different slope for each category of gender variable. So the relationship between age and salary is different for each category of the gender variable. Now, how do we execute the interaction term? First, we write the function, the dependent variable, and then all the independent variables, and then the interaction term. This interaction term is used using the colon sign. If I press Ctrl Enter, show you the summary of this results, then you would see that these two are our main effects. This is our intercept, and this is in the interaction term. If this interaction term is significant, then we can conclude that there is a moderating effect of gender on the relationship between age and salary. The rest of the interpretations are what we have already discussed in our previous videos. And let me also show you one more way of performing this interaction. We have used colon, and what colon would do is that you would separately identify the main effects, and then you would use the interaction of these effects. But what asterisk can do is you simply use these two variables and use an asterisk between them, and what it would do is it would automatically include both the main effects and as well as the interaction term. Again, the results are same. We just wanted you to know that there are different methods. There is this difference between colon and asterisk. Now let's create, interpreting these are somewhat difficult from tables. So we would create graphs, we would create visualization to interpret these results. For this, we are going to again perform this interaction, and we have the results in this object. Now for this, we are going to create a sequence of observations for the age, as we did in our previous video, and we have already explained it in our previous video. We are going to predict the values, the predicted values for male for different level of age that we have used over here between 35 and 45. And if I can show you these values, these are different predicted values for different age. So for age 35, the male predicted salary is 30,097. For age 36, its predicted salary, and so on and so forth. Similarly, we would create the predicted salary for female, combined these different, convert them into data frames, and combine these this data frame. If I can show you this data frame, it is plot data interval. Now you can see that we have gender, their age, and their predicted salary. Now we have all the data that we can use to create a plot. Now the only thing that we need to do now is create the plot. So we take this data frame. On x-axis we have age, on y-axis we have the predicted salary, this column. And the colors are, we would have different lines, and these lines are separated, would have a different color, and these colors are based on the gender category. We give the name of each axis and the title of this graph. If I can execute this, you can see that the slope of male is quite steeper as compared to the slope of female. So that means that the impact of age for each level of, for each 1 unit increase in age, salary of male will increase higher than salary of female. So that's what this graph is means. Similarly, the starting point of male salary is less as compared to females. Their intercept, the males earns lesser salary as compared to female, but the rate of change for male salary is greater as compared to female. Let's move to second topic, which is the interaction term between two categorical variables. We have these two categorical variables, which is gender and education. Let's execute this regression, and we are going to use this expand grid to create different combinations of these gender and age. Let me show you these values. So we have different combinations for each level of education. We have each gender category. And now we are going to predict for each of these categories the predicted values. So let me show you this predicted values. So now we have predicted value for primary level of education for male, a predicted value for primary level of education for a female, and so on and so forth. Once we have these predicted values, the next step is to plot them. So next, let's use ggplot to plot. On x-axis we have education, on y we have salary, and these are color coded using gender. We are going to create a line graph, and the groups are based on gender, right? So let's execute this, and you can see that we have different level of education, and for each level of education we have a line representing the males and female salary. So for example, we can see that female earns higher as compared to male at primary level of education, but that is different when we have other level of education. Now do remember, this is a hypothetical data, right? Lastly, we are going to do an interaction of two continuous variables. So we have age and marks. These are two continuous variables. Let's predict the regression, and then we are going to take the unique values of age and unique value of marks, calculate the predicted values, and let me show you this predicted. So for 34 age, 82 marks, we have this predicted salary. So for each level, for each combination, we have a predicted salary, and now we are going to plot it. But this plot looks quite messy, right? We cannot make any sense out of it. So a better way is that we reduce the categories of age and marks. So let me re-execute this regression. And now we just need to have 5 categories of age and 5 categories of marks. And then what we are going to do is we are going to take where age is greater than this first category, this first limit, and less than this second limit. So between 40 and 45, we are going to do similarly for the marks, predict the values, and predict the salary for these values. So for 40 level of education, for 40 age, 60 marks, we have this predicted salary. Similarly for 40 age, 61 marks, we have this predicted salary. Now we have limited these values, and lastly we are going to plot them, and we can see a nice graph. We can see that as age increases, salary increases for all different level of marks, but the one with the higher marks earns a higher salary. Its slope is higher, so if its age increases, the one with the higher marks would earn a higher salary for each unit increase in age. So I hope this video was useful. Stay tuned to this channel, because in our next video we are going to discuss three-way interaction. So do subscribe to this channel, do hit the bell icon, and thanks for watching this video.